Today we're going to talk about average rate of change, and we're going to spend a couple days talking about average rate of change. And in order to talk about average rate of change, we need to go back and look at the slope formula. And it actually turns out that I have one little mistake here on this front page. But the slope formula, we saw it last week when we were graphing lines. Slope is rise over run. And there's another way that we can write it, and that is we can use the Greek letter D, which looks like that triangle right there. It stands for delta, and that's where my mistake is. This should really say delta y divided by delta x. That means the change in y over the change in x. And the formula that we use for that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1 given 2 points. And hopefully that's familiar to you, but we're going to practice a couple of them before we get into the average rate of change. And what I can recommend here when we're finding the slope between these 2 points is that if this is tough for you, label the points. X sub 1, y sub 1, x sub 2, y sub 2. And then we need to fill in the formula. Now the next part for you is that the formula is right above this on your paper, but it's not right above it on mine. So just a reminder that this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we're going to fill that in. Well, y sub 2 is 2 minus y sub 1 is 3 over x sub 2 is 4 minus x sub 1 is 2. And then we simplify that. 2 minus 3 is negative 1. 4 minus 2 is 2. Negative 1/2. So we look at the next one, it's the same process. We're going to identify what's x sub 1 and y sub 1, x sub 2 and y sub 2. Again, you can look at the very top of your paper and you can see the formula, but because I cannot, I'll just write it again. And I find that's a good way to help me remember the formula. I don't know if that's a good way for you to help you remember the formula. But it's going to be negative 3 minus 4 divided by negative 1 minus 3. And negative 3 minus 4 is negative 7. And negative 1 minus 3 is negative 4. We need to simplify this just a teeny bit more. What's negative divided by negative equal? It equals a positive. So this is 7/4. Again, we're going backwards here so that we can move forward. So want to refresh your memory as to what is the slope so that we can apply it here in a couple minutes. But once again, label the points. Here's x1 and here's y1, x2 and y2. And we're going to fill it back into the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We fill that in, we get 0 minus 4 over 2 minus 2. 0 minus 4 is negative 4. 2 minus 2 is 0. And what does negative 4 divided by 0 equal? Well, we come over here and we try to type it in the calculator. Negative 4 divided by 0, and we get an error. And in fact, what happens is we're technically not allowed to divide by 0 because we get this error on our calculator. What we can say is that negative 4 divided by 0 is undefined. But let's think back, because we're talking about slope here. What kind of line has slope undefined? Really? A vertical line. This is going to be a vertical line. And I know that the paper didn't ask for that, but I just want to keep that fresh in our minds of what we're dealing with here. We're already familiar with average rate of change. We just might not have called it the average rate of change. When we're finding the slope of a linear function, we're finding the average rate of change. So slope equals the average rate of change. Now, we're going to look at it from a different perspective now. We're given intervals to look at on this graph. Starting with, it says use the graph below, then it's actually to the right, find the average rate of change between the following intervals. Well, x is between 0 and 3 is how we can read letter A. So we come over to our graph and we say, well, here's 0. And that point that corresponds to the 0 of the x is that 0, 5. And then we come over here to 3. And the point that corresponds to 3 is 3, 3. And what we can do on this problem here is we can use the idea of rise over run to find our slope. And when we do that, we draw a triangle. And what we're going to do is we're going to count. We're going to go down 2, and then we're going to go right 1, 2, 3. So down 2 over 3. But how do we represent down? Negative. So it's negative 2 over 3. Just a reminder, as we're coming from the left, if our line slants downhill, then it is going to have a negative slope. The other way that we can look at something on this graph here, for letter B, x is between 3 and 6. So 3, between 3 and 6, we're looking at the points that correspond to those x values. And we can use our ordered pair. We can use, the ordered pairs, and then our formula. Remember, here's x1 and there's y1. Here's x2 and y2. And we fill in to the slope formula that's at the top of your paper, which says 1 minus 3 over 6 minus 3. And 1 minus 3 is negative 2, and 6 minus 3 is 4. And I think I have something wrong here. Does anybody see what it is? 6 minus 3 is 3. What's wrong with me? Sorry. So we get negative 2 over 3. This last one here on part C, try it on your own. We're going from x equals 0 to x equals 6, but you have to find those points. What did you get? Well, here's our point for the 0, 0, 5. Here's our point for the 6. And what I can at least see up here in the front is that people drew the triangle. So once again, what we're dealing with when we deal with either the formula or the rise over run concept, this time it's 1, 2, 3, 4 down, which is our -4. And then it's 1, 2, 3, 4, 5, 6 for our run. And then we can simplify that fraction, which ends up to be -2/3. Well, what do you notice about our slopes in A, B, and C? They're the same. It doesn't matter what interval we picked, we still get the same slope. So what can we say about our average rate of change? Again, the average rate of change, which we sometimes abbreviate. Average, got to put the rate in there. Average rate of change. Sometimes I abbreviate it as ARC, or you'll see later on in the paper AROC. The average rate of change is constant, which means the same in a linear function. The average rate of change is constant, which means the same in a linear function. Every single time we calculate the average rate of change, also known as the slope, of a line, we should get the same value. We might have to reduce a fraction at some point, but we should get the same value. So there's a linear function. Let's look at a non-linear function like this picture here, because the process for computing the average rate of change for a non-linear function is the same as finding the average rate of change for a linear function. We pick 2 points and we use the slope formula. So on part A, we're looking at when x is between 0 and 4. By the way, something that I found some people are finding helpful is that they've been highlighting, and there's my disorientation, the highlighting of the x-axis. I'll fix that in a moment. And the y-axis. And I'm backwards. My y-axis isn't highlighted very well, but if I scoot that over, it's better. I don't know if that helps you. You do not have to do that, but I know that some people are finding that they just need to highlight it so they can keep track of where's the x-axis and where's the y-axis. But when we look at these, what we're going to do, here's 0, and here's 4. And we can identify these points. 0, 1. And we also have 4, 1, 2, 3, 4, 5, 6, 7. 4, 7. Once again, that's x1, there's y1. Here's x2 and y2. And we can fill in the slope formula. Use the slope formula. 7 minus 1. 4 minus 0. Well, 7 minus 1 is 6, and 4 minus 0 is 4. And I didn't show it on the calculator last time, but we can show it here. Alpha y equals, enter, will get us the fraction button. And we type in 6/4. which will simplify our fraction for us. So 6/4 becomes 3/2. So I infringed on my space here, but I'll do this. So once we get our first value there, we want to look at our average rate of change between 4 and 7. So there's our two values. And our point at 4 is 4, 7, and our point at 7 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 10. And once again, we can fill in the slope formula. Here's x1, there's y1. Here's x2 and y2. We get 10 minus 7 over 7 minus 4. Well, 10 minus 7 is 3, and 7 minus 4 is 3, and 3 divided by 3 is 1. Again, if you need to type that in your calculator, type it in your calculator. So we have one more calculation to do. And we can look at 7, which we just saw that point. 7, 10. And then over here, 13, well, I need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 13, 15. And once again, let's look at our slope formula. Here's x1, here's y1, here's x2 and y2. We get 15 minus 10 over 13 minus 7. 15 minus 10 is 5. 13 minus 7 is 6. Now remember, this is a non-linear function. It's not a line. What do we notice about our average rate of change? Well, what we notice about our average rate of change is that, I'm going to abbreviate, average rate of change is not the same. Over the different intervals. They're different. And that's what we can say. In a nonlinear function, the average rate of change, again abbreviating, average rate of change will not be the same. It changes, or it's different. Now, on my smartboard here, I have what's on the back of your paper at the back top. So on your paper it says continued when you flip over your paper. Mine is still here on the same page. So as you turn your paper over, we're going to look at part E now, which says draw lines connecting each point to the next. And what we want to notice, what do we notice about the slope, the rise over the run of each line, and the average rate of change over the same interval? So we just did the average rate of change on the front side. But what's going to happen now is we're going to draw a line from the first point to the second point. And we're looking at this from the perspective of rise over run. So here's our rise, and here's our run. Well, we rise. 1, 2, 3, 4, 5, 6. And we run 1, 2, 3, 4. So from 0 to 4, 6 over 4, which by the way simplifies to be 3 over 2. And if you recall, on the front of our paper, we had 6 over 4 when we used the formula, which we simplified to be 3 over 2. Well, if we go back and look at our next value here, okay, so when we go back to our next value, and we draw a line here so that we can come up with our triangle. Once again, we're looking at this from the perspective of rise over run. We rise 1, 2, 3, and we run 1, 2, 3. And once again, we have 3 over 3, which we can simplify to be 1. If you prefer, 1 over 1. But again, if you flip your paper over on the front, we came up with 3 over 3, which equals 1. And finally, between 7 and 13, when x is between 7 and 13, we're going to draw a line from here to here, and we're going to look at our slope. And sorry, the board's a little bit disoriented, but we get 1, 2, 3, 4, 5 for our rise, and 1, 2, 3, 4, 5, 6. So again, 1, 2, 3, 4, 5, 6. 5 over 6. And again, if you look at what we had on the front page, we also came up with 5 over 6. So what do we notice about the slope of each line and the average rate of change over the same intervals? Well, what we notice is that they are the same. Same thing. So as we finish today, go ahead and try these on your own. Remember, identify the point and use the formula, then use the rise over run, the triangle, and then hopefully they match.